I think I did some live chess back in the day, but that is really back in the day. That's like 3 or 4 years ago. So this is all looking good. Again, please do pop in the chat if you're not sure about something. Today we are going to talk about sketching graphs. So I'm going to do some linear graphs, then do some quadratics, which is generally what comes up here. And then finally, we're going to look at some cubic graphs. We'll go a little bit beyond syllabus, so I'll look at maximum minimums as well, which usually are not required, like in terms of graph sketching, but generally useful for you anyway when it comes to doing the differentiation. So we get a little bit of differentiation in there as well. Darkfire, curve graphs, do you mean like reciprocal graphs, like 1 over x, or do you mean like sine graphs, cosine graphs? So yeah, today I'm focusing on linear, quadratic, and cubic. Really, it's a way of me testing that the software works and the chat's working and everything is working here. But again, we can do more of this as well. Okay, hyperbola. If we get time, we'll see how we get on. Right, let's get started. So all the sketches. So whenever they ask you to sketch a graph, it basically contains all the information you can easily take away from the function. So usually that means the roots, the y-intercept, the shape of the graph, what kind of graph it is, and that's all you need essentially to put on there for iGCSE. Now we're going to start off with something nice and straightforward. So we're going to start with a sketch. Now this is not plotting, but a sketch of y equals 2x minus 1. So we've got our checklist here. So whenever I work with a linear function, quadratic, cubic, or any other function for that matter, then I usually have my checklist here to make sure I'm doing everything correct. The first thing I'm going to do here is work out the y-intercept. So if I want to work out the y-intercept, as it says here, I set x to 0. Now this is really easy for a linear function. So if I set x to 0 here, wherever I see an x, I put a 0. Then we do minus 1, and 2 times 0 is 0, minus 1 is minus 1. And I'm sure you've learnt this with the y equals mx plus c here, when the c here represents the y-intercept. Just a quick question from Abdul here. So is it advised to make new points like filling the gaps between points to make a better curve? And is that advised? That kind of depends. Usually you don't need that for sketching functions. An exception I might make to that is sine and cosine. So if you draw trigonometric graphs, then it's quite useful to know some exact values, which I just talked about in the community post. So that is useful to know, but generally not. Okay, we have y-intercept here of minus 1. Now we want to find the root. Now notice with a linear function, there's only one root, and we set the whole function to 0. So we do 2x minus 1 is equal to 0. Can anyone in the chat tell me then what x has to be here? See who's quick in the chat here. So 2x minus 1 is equal to 0. What does x have to be? Can anyone answer that straight away? Let's see if the chat is working here. Ah, the tension here. Thank you, Nazif. Yes, it is equal to a half. What we do here, we add 1 on both sides. So this cancels, leaving us with 2x equals 1. And then what do we do to get x on its own? We divide by 2 on both sides. And that gives us x is equal to a half. Perfect. Good. We've got half, 0.5. Both are absolutely fine here. Now we talk about the gradient. So the gradient of a linear function here is just the number in front of the x. So our gradient here is equal to 2. And that means that when we draw the graph, we're going to have a steepish line going upwards. I generally go from left to right, go upwards or downwards positively. So if I draw a sketch of this, bringing all the information together, again, very easy for a linear function here. So we've got a y-intercept of minus 1. So I'll put that down here. We've got our x-intercept of a half or 0.5, and we're going upwards. So my sketch here, that wasn't the best start to the line. Here we go. Let's try this again. There we are. And then we just draw a line upwards. Again, in the exam, of course, you'll have a ruler to make sure that you can do this. Okay, how do we find that in the chat? Are we thinking that's okay here? I'm assuming this is all looking good. How do we know if it's linear or any other? Good question. So we know this is linear because we just have an x. We don't have an x squared or an x cubed here. So we have x to the power of 1. Again, we could write the 1 in if we want to. That tells us it's linear. It tells us it's a straight line. Good question. Ginger, can you make a new video on all of iGCSE Maths, Paper 2 and Paper 4? Yes, so like an updated 2025 version. Certainly that is on the horizon. Hopefully that can get done in time. Again, lots of different kind of videos coming out. If you're part of my newsletter, you'll know there's a binomial distribution video coming out for A-Level Maths Paper 5. That is coming out tomorrow. Okay, so with linear functions here, again, sometimes they'll put it in a slightly not very nice form. So x plus y is equal to 7 here, but we still have the same checklist. So y-intercept x to 0. So when x is 0, then that means then y is just equal to 7. If we work the other way around, so make y 0, so when y is equal to 0, then imagine then the y disappears. So I put a little line over it, and that means x is equal to 7. So it means it goes through these two coordinates. It goes through 0, 7 and 7, 0. Now the gradient is a little bit more difficult to look at straight away because it's not in that ideal y equals mx plus c form. So can anyone in the chat tell me what I do with this equation so I can find out the gradient, the steepness of the function? This video will be available after the live. Yep, it will be. I can also put the PowerPoint, of course, into the description as well. Not a problem. Can anyone tell me in the chat, what do I do with x plus y equals 7 so I can work out the gradient and how steep it is? Good, to make y the subject, put x to the other side, exactly. So we want to get the y on its own. So what's the opposite of adding x? We minus x on both sides. This cancels, giving us y equals minus x plus 7. And remember what I said in the first slide, the number in front of the x tells me the gradient. So it's going to be this minus 1. Okay, remember minus x is the same as minus 1. So our gradient here is equal to minus 1. That means we're going to have a line that then slopes downwards instead. So if we put everything together here for our sketch, so let's draw a nice sketch here. We have 0, 7, so we'll put 7 here, we'll put 7 here for 7, 0, and then we just join it up. Notice all the information should link together in order to make sure you've got the proper sketch. And you'll see this with quadratics. If something's not quite right, then usually something's gone wrong somewhere, so we have to be a little bit careful. Okay, so that's a nice warm-up of linear functions. Generally don't get you to sketch it, they get you to plot it, but a good way to warm up. What we're going to look at now is a quadratic function. So we're going to start with something a bit tricky here. So we're going to start with y equals 3x squared plus 5x minus 2. And we're going to sketch this from essentially first principles. Notice my checklist here is updated. So for quadratics, I have 5 steps here. Notice steps 4 and 5, you can take different approaches, essentially, to find the vertex, so to find the minimum point or maximum point. But again, we can use lots of different methods here. So the first thing that we do is we look at the a value. Now the a value of our quadratic here is equal to 3. Now because a is positive 3, as I like to teach my students here, this is going to be a happy face, yeah, or a U shape. Generally, I get to describe this as a happy face. Now, most students then remember that our quadratic, which is a parabola here, has this U shape here, a nice happy face. What is a vertex? A vertex is simply either a minimum point or a maximum point, but we will come to that in step 4. So we know it's a U shape to start with. Now we want to find the y-intercept. So when x is equal to 0, we put in wherever we see an x, we're going to put a 0. So 5 lots of 0 minus 2. And most of you probably have already seen this. Salutations, karma. And if you put 0 into here, this term disappears, and we have our y-intercept of minus 2. So we know the graph goes through minus 2. So we've done this part and we've done this part. Generally the easier parts here. Now we do the difficult part, which is find the roots. So we solve for x. That means we want to have y as 0 now. So that means we're going to have 3x squared plus 5x minus 2 is equal to 0. Okay. Karma, are you cooked? You're definitely not cooked at this time. And we've still got 3 weeks, I think, 3-4 weeks until the exam starts. So don't worry, Karma, you are not cooked. Again, this is the whole point of doing these live videos and all the videos on my channel. If you've watched pretty much all of them at least a couple of times, then you'll be fine for the exam. Now, in order to solve this, we have lots of different methods. We have factorizing, got quadratic formula, we've even got completing the square, which I mentioned over here as well. I'm going to show you my quick way of factorizing if it's possible. So I know some students do something called splitting the term, which is good, but it does take quite a long time. Let me show you the kind of cheat method here. So we're going to go for brackets. The only way we can get 3x squared is if we have 3x and x. Okay, and now we want two numbers that multiply to give me minus 2, and order matters. So we have minus 1 and 2, 2 and minus 1, 1 and minus 2, and minus 2 and 1. Those are the 4 combinations that could work here. Now notice I want a fairly big positive number compared to the minus 2. So generally that means that I want the biggest positive number on the outside, so the plus 2 here, so I create a big lot of x. Notice when I do FOIL, expand the bracket out, 3x times plus 2 is 6x. So I'm using this middle term to help me get an idea of exactly what should go in the bracket. If this is plus 2, then this has to be minus 1. Now, if you're not happy with that and go, oh, I'm not sure if that could actually be correct, again, we can always double check this by expanding the bracket. So 3x times x is 3x squared, 3x times 2 is plus 6x, minus 1 times x is minus x, minus 1 times plus 2 is negative 2. If we collect up the like terms, we do get back to the same quadratic that we had before. So this is a nice little hack in order to actually factorize quickly. Very important for A-level and IB in the future. Now we've done this, we can then solve the quadratic here. So we either say that 3x minus 1 is equal to 0, or x plus 2 is 0. If two things multiply to give you 0, then 1 has to be 0. Therefore, then, if I solve this equation, 3x equals 1, x is a third. And here, x plus 2 is 0, x is minus 2. So we know that the quadratic will go through the x-axis at 1/3 and minus 2. Super. Okay, so we've got our x coordinates, so the roots here, so we can tick that off. And now I'm going to show you my very quick way of finding the minimum point. So this is a useful technique to be aware of. So if we take the axis of symmetry, this is a formula that's not always taught to iGCSE students, but you can of course use it. And this is equal to minus b over 2a. Now what does the b and a stand for? Remember, it's the numbers in front of the x squared and the x here. So we can use this in order to find the x coordinate of the minimum point or maximum point. Now because we have a U shape, we're going to have a min point because of the shape of the graph. So we kind of already know this. Now, if we do minus b here, well, we've got plus 5, so we're going to have minus 5. And then 3 times 2, that's equal to 6. So we know the x coordinate is going to be equal to minus 5 over 6. Really nice formula to learn. It's not given on the formula sheet, but it helps you a ton to work out the minimum point. Now, to work out the y coordinate, we just put in that value. So when x is equal to minus 5 over 6, we put that into the original equation to work out then the y value. Now this is of course where you use your calculator, so make sure you've got your calculator to hit. The turning point, yes, exactly, Trent Stearman, that is what we are working out here. So if I put this into my calculator, again, you need to be pretty quick with the calculator in the exam. The nice calculator hack video, that gives us then minus 4 and 1 over 12, sorry. if I put this into the calculator. So that means our turning point, minimum points, vertex, lots of different words for this, is minus 5 over 6 and minus 4 and 1 over 12. We can also do a double derivative, yep, to work out its minimum maximum. That is true. And for cubic, I will tell you that at the end of this video, so I will go through it. Okay. There is no second turning point in this particular example because we have a quadratic, therefore is only one turning point. So if I do a sketch of everything that I've talked about so far, so again, just doing a quick x and y axes here, let's put all the information in. So we have, first of all, is a happy face. We go through 0, minus 2. So we're going to go through minus 2 here. We have 1/3 and minus 2. So we've got minus 2 and 1/3. And we've got the minimum point down here, which is minus 5 over 6, minus 4 and 1 over 12. Notice all the information that I've worked out for this particular question all fits together, because when I join this to make a happy face, notice I go through the x coordinate here, I go down to my minimum, I go through the y axis here at minus 2, and then go through here. And so all the points make conceptual sense, and I do get a quadratic that I'm looking for. Now, of course, in the exam, do make sure that that graph is far smoother than I've done there. But notice nothing's gone kind of weird here. Notice this minus 2 is not a plus 2 or something. So everything fits with the image that I have so far. This would probably most come paper 4. It could be both, to be quite honest. Like, doing this part is kind of annoying on a paper 2. This is true. They might make the numbers easier. You'll see an easier number example in a moment. But yeah, generally a paper 4 would make more sense for a question specifically like this. Okay, do we have any questions in the chat about this so far? We're going to do one more quadratic, and then I'm going to do a cubic afterwards. Can you show dy by dx? You'll see that in the cubic. Would you say just banging past papers is the best? Certainly we're like 3 weeks out. Yes is a quick answer. Like doing lots of past papers, getting lots of familiarity, but really important is to follow up on those past papers with any topic. Say you really struggle with vectors, for example. I've done a vectors crash course. I've done 2 videos on iGCSE vectors. Do use those to really fill that gap. So you're using those past papers not just for practice, but you're using them to fill in those gaps. Those more difficult topics like sketching graphs, like vectors, like differentiation. Exactly. Hey Ginger, in total is only 3, right? Linear, cubic and quadratic. For this video, yes. You still need to know reciprocal functions, so 1 over x, 4 over x, that kind of thing. Also trigonometric graphs, so sine, cosine and tangent. That's also important as well. How to practice non-calculator paper. I've made an exam sprint video, which is really good. So goes through, I think, about 30 minutes of typical non-calculator skills that you really need to be quick at. And if you want extra ones, then you can buy them, I think, for 20 euros in the chat. What's the hardest topic in your opinion, Ginger? Ooh, what's the hardest topic? Some of the vectors questions, like at the top end, like those extended vector lines, can be kind of weird at the start. Differentiation has always been a difficult topic, for sure. And some of the sort of hardcore algebra topics, as I like to call them. So quadratic simultaneous equations, where they combine 2 difficult topics together. I think that's pretty tricky. Okay, let's do one more quadratic here. So we're going to sketch this function. Notice in a slightly different form here, it's already in factorized form. That actually makes our life a bit easier in some ways. Now, first of all, we need to establish if the a is greater than 0 or less than 0. We can do this by just expanding out the quadratic here. So x times x is x squared. X times minus 3 is minus 3x. Minus 1 times x is minus x. Minus 1 times minus 3 is plus 3. And we can simplify this to x squared minus 4x plus 3. So now we've got both versions of the quadratic here. which is pretty useful in order to work out all these different things. Now notice we've got a 1x squared here, so a is equal to positive 1. So we've still got a happy face here. Perfect here. So a U shape. I like happy face, it's nice. Now we want to work out the y-intercept. Now notice this plus 3 here at the end will be our y-intercept, because when x is equal to 0, that means then that y is equal to 0 squared minus 4 lots of 0 plus 3 equal to 3. So we know it goes through 0, 3. These two steps are usually the easiest to do. And now we're going to find the roots. But notice we've got this factorized form instead. So when y is 0, we then know that x minus 1, x minus 3 is equal to 0. Therefore, either one bracket is 0, so x minus 1 is equal to 0, so x is 1, or x minus 3 is 0, and therefore x is equal to 3. So this was an easier example in some ways because we're already given this factorized form. And now we can do the vertex or axis of symmetry. Let's do completing the square this time. So let's do a different approach. So if we take x squared minus 4x plus 3, to do completing the square, and I've done a really nice video on this topic specifically on completing the square, the way that we set this up is we find half of the b term, so that's minus 2, and then we write the expression x minus 2 all squared. Okay, and what I get students to do here is consider, well, x minus 2 all squared is the same as x minus 2 times x minus 2. If we expand this out, we get x squared minus 2x minus 2x plus 4, and that simplifies to x squared minus 4x plus 4. So this normally gives us x squared minus 4x plus 4, but we want x squared minus 4x plus 3. So what do we do to 4 to get to 3? Well, we subtract 1. So now I've put it into this completing the square form, which is really useful because we can read off the minimum point here directly. So our minimum, let's not use that, equals the minimum point is going to be the positive version of this, so be careful with this, 2, and then we just read off this value, so 2 minus 1. So we've got all the information we need now. We've got 0, 3, we've got 1, 0, we've got 3, 0, and 2 minus 1. Let's now check that we actually do get a quadratic function that makes sense. So what do we have first? We have 0, 3. So let's put that there. Then we've got 1, 0, and 3, 0. So 1 and 3. And now a minimum point at 2 minus 1. Yeah, this is all making sense. It's all fitting together because notice now I can draw a nice smooth sketch. Now I will do my best on a computer. So we go down, 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 down. We go through the first root. We go to our minimum point and then we go upwards. In anything I've done in this video today, you can double check by actually using GeoGebra or Desmos to actually put these functions in yourself. But I thought I'd go through two examples here, one where it's in factorized form already, and one that's kind of a standard quadratic, with that step 3 being a bit more tricky. Okay, in the chat, are there any questions about what we've done so far? Wow, so much in the chat. Okay, 2 minus 1, I'll just leave this on in the background so you get views. Good luck studying, guys. Okay, thank you, Papa Zeon. Hey, are you planning on taking any more live classes like this? So this live really, I mean, I made 60,000 subscribers. So you can say woohoo in the chat. So thank you. We got to 60K. Yeah, basically this video is just to explore, first of all, if my streaming software is working fine, the presentation, so how to break up the frames and the chat, and you can actually see me as well going through this. So maybe like modifying the overlay from OBS. So it's just really practicing all the different skills involved in doing a live. I haven't done a live, again, you can check on the channel 3-4 years ago, like ages ago. And I'd like to do some more lives. Now it's the Easter holidays, so we have more opportunity to. Yep, this video gets uploaded directly. Again, it's not just for members, it's for everybody, so it just goes in. The axis of symmetry gives you the x value of the turning point. So if we take this quadratic, which was x squared minus 4x plus 3, excuse me, the axis of symmetry is a really useful formula. I don't know why teachers don't teach us more. So it's minus b over 2a. It's the first part of the quadratic formula. So our b is minus 4, so we take minus b, so plus 4, divided by 2 times 1. That equals 4 over 2, which is equal to 2. And this value of 2 that you get from the axis of symmetry gives you the x-coordinate of the minimum point. So it's a very useful technique, and it saves you a ton of time, particularly those more difficult completing the square questions and just avoiding that whole situation. Now, if you're going on to A-level Maths Paper 1, sometimes they design the question you have to use completing the square, so you still need to learn the technique. And in most courses, whether you're doing IB or A-level, you generally do need to know it in some shape or form. Do you know where I can practice some paper 2 questions? Yes, I made an exam sprints video which goes through those sort of standard paper 2 skills and non-calculator. You can find it in my videos. Type in iGCSE Maths Paper 2 Ginger, and if you want more of these exam sprints, I've made an extra 4 sets of them, and you can buy them in the description. Oh, my professor didn't tell us. Yeah, it happens quite often in mine, I'm afraid. Yeah. Like, they don't tell you the axis of symmetry, they stick to doing completing the square or differentiation, which we'll look at next, actually. So it's a nice tool to have up your sleeve. If you're going on to IB high-level AA, this trick, when you go into cubics and quartics, you'll see some of these concepts of ideas taken a bit more advanced, but I'll just leave it at that for the time being. Do I take paid classes, perhaps online tuitions? Certainly something I've considered, maybe in the next few weeks or so, maybe a couple of paid sessions, maybe sort of maximum 15 students, something like this. And we can work in a very similar way to what we're doing here. Something definitely to consider. I'll let you know via my newsletter and via the community posts. How do you factor this? Oh, good question. I'm just looking at it here. You usually have to use the factor theorem or remainder theorem. That's on AdMaths, if you do AdMaths, or on the IB courses. That's something I won't talk about, obviously, in this video, but something I think I talked about in my AdMaths video when I went through that video. Watch a video on this topic, and then boom! Yeah, exactly, Dirav Mal. Yeah, you just seen this sketching graphs topic. Before I lose my voice, I've just finished school for the holidays. So I'm a full-time teacher, by the way, if you're not aware of that. So that's why the content comes out as I can, basically. The hardest thing is sequences, really. Like, watch my sequences video, like particularly quadratic sequences that everyone freaks out about. Just watch my video, it'll make a lot more sense. Okay, right. So if you want to go this question yourself, at the end of the live, I'll put this PowerPoint in the description, and you can have a go at this question yourself. So 7 minus 6x minus x squared. What I'd like to talk about is a very similar question to the specimen paper 2, and that is a cubic function. However, if they give you a cubic function on iGCSE 0580 Maths, it will be in this kind of factorized form. So don't feel like you'll have to use the factor theorem, remainder theorem to do these. So let's talk about, first of all, the shape of the graph. Now, notice these x's. So if I multiplied all of this out, I would get x times x times x, which is equal to positive x cubed, or 1x cubed. Now, because it's a positive x cubed, so a is equal to 1, the graph goes uphill. So what do I mean by this? A general cubic has two different shapes. Either it goes this way, or for a negative, it goes this way. And because a is equal to positive 1, it's going to have this general shape here. Okay, so that's what I mean by going uphill. Imagine you start here and you're hiking and you're going all the way up to here. Then you're essentially going uphill. You've got a little dip here, but the general trend is that you're going uphill. So we know from the a equals 1 that the graph goes uphill. Perfect. So we can tick this off. Now we need to find the y-intercept, so set x0. Again, we've looked at this before, so when x is equal to 0, y is equal to, well, 0, 0 minus 1, 0 plus 1. And anything times by 0 is just going to equal 0. So we've got our y-intercept at 0, 0. And now we need to find the roots. Now notice it's in a very nice form, which it will be for iGCSE 0580 maths. So we have it in this form. And that means then that either this x is 0, which we already knew from the y-intercept anyway. X minus 1 is 0, so x is positive 1. And we also know x plus 1 is 0, so x is equal to negative 1. So we know it's going to cross at 0, at 1, and at minus 1 as well. So that is useful information to know. Now I know a few people have asked about this, about how do you actually work out the maximum and minimum points. Now as I put here, it's not usually required for iGCSE, but if you're moving on to other courses and you're looking really on that extension, those unseen kind of questions, let's at least talk about this. So if I expand all this out, notice we have it in the difference of two squares form. So if I leave this x alone but just expand the bracket, well, we've got x squared plus x minus 1. These two cancel, and so we're left with x brackets x squared minus 1. So this is a difference of two squares. You should recognize that from the iGCSE course. Now we can just multiply out this bracket. So we get x times x squared is x cubed, and then x times minus 1 is equal to x. So if we expand all of this out, then we get this particular fairly simple cubic here. Now, to work out the maximum minimum point, we have this method called differentiation, which some of you have talked about in the chat already. So how do I differentiate this function? How do I work out dy by dx? Well, we take the 3, we bring it to the front, so that gives us 3x, and then we reduce the index by 1. So we go from 3 to 2, just like that. For this one, we do the same process. So we take the 1, bring it to the front, so we have minus 1, x, we reduce the index by 1, so that gives us x to the power of 0. Now, you should all know, this is a really important fact, anything to the power of 0, so x to the power of 0 is equal to 1, 7 to the power of 0 is equal to 1. My favourite football team, Derby County, they're in the second league, hopefully they'll survive this season. To the power of 0 is also 1 as well. So anything to the power of 0 is 1, and so this term here just becomes minus 1, like so. So we've now found the derivative of the function. Now, why do we care about such things? Why do we care? The reason for that is to find any stationary points, so minimum or maximum, so I'll use min or max. We set our derivative now to 0, so we take the 3x squared minus 1, and we make it equal to 0. So we're going to solve that equation. So I'm going to give you a moment in the chat. Can you solve that equation for me? 3x squared minus 1 equals 0. Please be careful. That's all I'm going to say to you so far. Let's see if anyone can answer this. I'll take a little break and take a little coffee. Okay, so we've got our square root of 1/3. Can we be a little bit more specific here? So I agree, 3x squared is equal to 1. X squared is equal to 1/3. Good, plus and minus. Thank you, Hassan. Really well done. So we've got the plus and minus the square root. That makes a big difference for this kind of question. I'm sure your teacher has said when you find the square root of a number like 64 is equal to 8, that's the principal root is what we like to call it. But when it comes to equation solving specifically, then you get two answers. So there's a difference between just knowing a square root and square rooting in an equation. There are two different things going on. Nice. So we've got plus and minus the square root of 1/3. Now, just to test your surd knowledge, because that is also important for paper 2. So we've got plus and minus. We do the square root top and bottom. We get 1/√3. Can anyone tell me in the chat how I rationalize the denominator here? This is a phrase you need to know from surds. How do I rationalize the denominator here? Let's see if anyone can do that in the chat and know what I'm talking about, because it's really important. It comes up now, or will do a ton. So how do I rationalize 1 over root 3. What answer do I get? Trench has got the right idea. Can you give me an answer? Good, yeah, exactly. Well done. So we get the plus and minus the square root of 3 over 3. Generally speaking, you should rationalize the denominator if you get the chance to do it. Whether they take a mark off at iGCSE for this kind of question, I doubt it, but they certainly could do that. Now, once I know the plus and minus root 3 over 3, once I know those two answers, I can substitute that back into my function to work out the y coordinate. Now, I'm not going to do that now, but if you wanted to work out the y value, we take plus root 3 over 3, and then we can work out y, and then when x is minus root 3 over 3, then we can work out the y coordinate there. So notice we're going to have a maximum point and a minimum point. Now I haven't talked about the second derivative yet, about working out if it's a maximum or minimum, but we can be a bit lazy in this question. And there's a reason why. Can anyone tell me why I don't need to use the second derivative test to work out which is a maximum, which is a minimum? So can anyone tell me that whilst I start drawing our sketch here? Let me just duplicate this slide. Can anyone tell me why I don't need to use the second derivative test? Okay. One is negative already. Yeah, I think you've got the right ideas. So let me just draw in my sketch. And this is why the y coordinate doesn't matter too much. I just want to show the knowledge here. So we've got, goes through 0, 0, goes through 1 and minus 1, wasn't it? Yeah, 1 and minus 1. 1 here, minus 1 here. Now, if you take the general shape of a cubic function, general shape, notice it will always have a shape when it's positive, like this. So I've drawn this as best. Should be symmetrical, by the way, but that's a point for a different video. So notice the first point always has to be the maximum here, and the second point always has to be the minimum, because we know the shape of the graph. It's our very first thing that we did. So if we go minus root 3 over 3, and whatever the y value is comes here, and then root 3 over 3, and whatever the y value is, then will come here. So you can use the shape of the graph to actually work out if it's a maximum or a minimum. Okay? But yes, you can use the second derivative test as well. But notice I'm trying to save you time in the exam. If they say, okay, I want you to draw a function and give the minimum maximum points, you don't want to be sitting there doing another derivative, substituting values in, seeing if it's less than 0 or greater than 0. This is a much quicker and refined way of doing it. So I'm trying to give you lots of tips in this video. So just to speed you up in the exam so you can get that extra time to really work on those difficult questions. Yeah, does this apply for 0607 paper? I don't think so, because you've got the graphical calculator for 4 and 6 anyway, but this is good knowledge generally to have when you go into IB or A level, okay? So nice little trick to know for cubics, that you can use the general shape to know where the minimum is and where the maximum is. Okay, any questions in the chat before we do a actual genuine specimen paper question based on what we've talked about so far? Could I do more mensuration videos? I've done 2. I've done an ordinary mensuration. I've also done an advanced mensuration video. So again, type in to YouTube, iGCSE mensuration ginger. They should come up. Hey, not related, but what questions are more likely to come in paper 2? Yeah, so something like exact trig values, the exact trig values, surds has to come in non-calculator. So there are certain topics that have to be non-calculator based. They don't ask minimum, maximum iGCSE. Probably to calculate it, like I just did in this question. Probably not, but it's good knowledge to have anyway. And if they want to try and extend those A-star questions, which they always do some twist every year, like I predict the exams, and I predict it with like 60% accuracy, 60, 65%, but they'll always put something in there to try and really differentiate between A candidates and A-star. Atmas video, there will be one coming out fairly shortly. I'm not going to tell you which topic it is, but it will be coming out. Do they ask to find maximum in sketching graphs at iGCSE? Not that I've seen yet, but there's no reason why not. You have the skills for it. Prediction papers are already on my website. So you go Ginger Mathematician prediction papers into Google. You will find those for iGCSE, both paper 2 and paper 4, and A-level papers 1 and 5. Okay, so to finish this video today, we're going to do part 26a using what I've literally just said here. So on the diagram, sketch the graph of y equals f of x between our domain. So notice this word we should be more familiar with now. So what x is allowed to be. Now it's given, obviously, on our diagram, we're going between -3 and 4. So can anyone tell me what the first stage is? It's a 3-mark question. Probably takes you 4 minutes in the exam. What should I do so far? What should I do? Yeah, the prediction papers are paid for, but it's a way of supporting the channel. So it supports all the other content that I do, and there's tons of content out there. Expand! No, don't expand. Please don't expand. Please don't expand. Don't need to expand. Definitely don't need to expand. Okay, first thing, shape of the graph. First thing, shape of the graph. So we've got x times x times x. So we've got x times x times x. Yeah, if you expand, it just takes up too much time. It doesn't really help you too much. It's an x cubed, so it's going to be uphill. So we go like this. So it's going to be this shape of graph. So that's the first thing that we should be looking at. Pudding calculator. Yeah. It's paper 2, not paper 4 question. What do we look for next? Equate each to 0, find x roots. Yes. Again, try and systematize this. So next thing would be y-intercept. This will be the next thing I do, and that means set x to 0. If x is equal to 0, using the f notation, which is fine. So 0, 2, -3. Remember, anything times by 0 is just 0. So we know it's going to go through 0, 0, just like the example we did before. And yes, now we've got the roots. Now we can talk about the roots here. So the roots, called lots of different things. Roots, x-intercepts, solutions. There's another word I've forgotten. So we had x plus 2, x minus 3 is equal to 0. So either x is equal to 0, x is equal to -2, or x is equal to +3. So we know it goes through -2, so -2 here. We'll put 3 over here. And now we've got everything that we need in order to draw this function. Yeah, next is x-intercepts. Well done. Hello, Mohammed. So we go up through the function. Now notice we always cross the axes. We don't just touch there. And there's a reason for that, which I'll talk about in one of my A-level videos. And then we go up like this. So we've got our sketch here. If we wanted to, we could try and work out these maximum points. But for this question here, it's only a 3-mark question. They certainly will give you more marks to work with if they wanted those points. Notice that it's very clearly in the question here, show the values of the intersections with the axes. And that's what I've done. I've shown here, here, and here. If you look at the mark scheme here, so you'll see, so correct sketch without any labels. So the shape of the graph, we've got -2, 0, and 3 indicated. So here, here, and here. If you have the general shape of the graph, it goes through 0, 0. There's a maximum here, a minimum here, and again, just continues in both directions. So that's where we pick up the 3 marks here, using what we've talked about in this video. Because we have a given, true, because we've got a given domain, it doesn't keep going. This is true. Again, I'm usually taking it where it goes. That is a good point there. I will cross out my arrows because it just stops at -3 and 4. Yeah, that's true. Can't make a table and add the values for x. This is a non-calculator question. This comes from the specimen maths paper 2. So we can't use the calculator for this. But you could make a table yourself manually and actually work out these values. That's true. It takes a lot of time. Can you go through the roots again quickly? Yes, I can. So we've got the roots. We just take our function, make it equal to 0. So let's do it over here. And please do ask questions. So that means then either this is equal to 0, so x is 0, or this bracket is equal to 0, x plus 2 is 0, and so to get x on its own, we -2 on both sides. This cancels, giving us x equals -2. or the other bracket is 0. So we don't know what 0, but we know one of them has to be to give us 0. And that means we add 3 on both sides. This cancels, giving us x is equal to 3. Perfect. Could you go through how to know what shape to use for cubic? This is one you just have to learn off by heart. So knowing what a cubic looks like, a quadratic looks like, linear. We're not going to talk about trigonometric functions or reciprocal functions, but you need to learn those shapes. Do you have any videos on the vector questions where the vector expands? Yes, I do. If you type in iGCSE Advanced Vectors, Ginger, you will find it. Yes, you will. iGCSE Maths B, I found the video is really helpful. The workings are the same, yeah. Between Edexcel and Cambridge, it's pretty much similar. If you're looking for predictions for ratio, I'd recommend Mr. Wright Maths. He's already done some predictions for iGCSE Maths. I'm not sure if it's A or B, but he's definitely done it for Edexcel. Can we always assume the equation is equal to 0? To find the roots for C, yes, we can. Exactly. Thank you, Hassan. I did Papazion in the iGCSE Advanced Vectors video. Have you found the right one, Papazion? Just type in iGCSE Advanced Vectors, Ginger, and you'll find it. Yeah, Mr. Wright Maths with a W. So W and then Wright. Is the threshold going to be low? From the feedback that we've got from the February exams, so February 2025 exams, it does seem like a bit on the easier side. So who knows what happens with the thresholds, because it's a slightly new course. And some teachers, have forgotten to teach certain things. That usually happens, in a year change like 2025. So, yeah, it's going to be hard to predict the grey boundaries compared to previous years. What's that thing where you have to make both equations the same by finding the ratio of both? I'm not sure what you mean, Trench Demon. Both equations the same. Yeah, I'm not entirely sure which question, but again, you can always send any questions to me, gingermathematician@gmail.com. Again, I do read all the emails. I try and answer as many as I can. May June predictions are already out, really, for this course, the 0580 Maths, International Maths, Add Maths. They're all on my YouTube channel. This is easy to say the paper will be easier or the threshold will be easier. I think the paper will be slightly easier than you probably think it will be. And that might mean the thresholds are quite high. That's my conclusion. Could you tell us the graphs need to learn off by heart? If you've checked out my cheat sheet for iGCSE, I think it's in there. Could you treat those questions where you have to find the inequality shaded? I did an updated video on shading inequalities. I did an older one and I've got a newer one that's already out on the channel. Again, type in iGCSE shading inequalities Ginger, you'll find it. Do you think the pure math 1 threshold will be lower? That I'm not entirely sure about. I don't think it's doing too many changes for A levels, so I don't think that's going to be particularly low. I don't think so. Centrist, by the way, there is a new A-level Maths Paper 5 video coming out tomorrow, so do stay aware. Right, I think I'll give it another 5 minutes and I'm going to be stopping the video. Are there any more questions in the chat that I can answer here? I'll put the mark scheme for this question up on the board. Matrices, not in the syllabus, hasn't been in the syllabus since 2019. I think it's a while ago. Yes, it does apply to a quadratic graph. So make it the whole thing equal to 0 and solve. Exactly. Threshold prediction for FM. I haven't seen the entire paper. Again, and difficult to predict thresholds, particularly this year compared to previous years. Yep, no problem, Hassan. Again, do check out all the new videos coming out on the channel. Again, I'm trying to produce as much as possible for the exams. Are you going to post this video? As far as I'm aware with lives, as soon as I've finished, it should upload automatically to YouTube. And again, this won't be under a paywall or anything. This is out there for everybody. Thank you, Mohammed. Much appreciated. It's great to actually talk to the community like kind of live. It's very, very nice to see. But no problem. Again, I keep producing content. head towards 100,000 subscribers. We'll see. We'll see how close we get after the exam period. How often do you do lives? This is the first live I've done almost ever. I used to do chess lives back in the day. Most people here are Pakistani, okay. But hopefully I'll do some more lives if this is popular. I'm certainly happy to do some more lives on particular topics you're struggling with. Thank you for the recommendations, much appreciated. Can you share 0580 latest syllabus for exams? I'm sure I did that in a video somewhere. I can't remember where though. Goodbye, sir. Yeah, goodbye, Rezen. Nice to see you. Do iGCSE grade certificates really important for the future? How many fans showed up videos to the whole class? Lovely to hear. Like the feeling that like my videos are going to like Lahore or Islamabad is absolutely amazing. Absolutely amazing. Are iGCSE grade certificates important for the future? Yes, is a quick answer. It gets you onto the different courses. Most schools will restrict the options that you have depending on the grades that you get. So if you're getting A grades, that puts you on pretty much any course that you want. If you're getting C grades, that might limit your options like IB or A level. Am I currently teaching in the school? Yes, I teach full time. So a brief background, I'm a maths teacher for, oh God, how many years now? 13, 14 years, I think. Again, I have to check the maths on that. I worked in the UK for a few years. Then I worked at a British international school for 9 years. 5 years as head of department. So I was head of department for 5 years. And now I'm actually working in a German school, so a bilingual school. So I'm doing a mixture of different kind of courses. So there's always a bit of cricket chat. I'm a big cricket fan, by the way. A little bit disappointing as an England cricket fan, but yeah, it is as it is. But I remember the good old days. The good old days of Graham Gooch is probably a little bit before my time, but Graham Thorpe, he used to save us so many times when I was young. It's amazing. But it's good to work full time, like as a teacher, because you're really getting the experience of teaching students and seeing what they actually struggle with. So having the full-time experience is good to see exactly where those pain points are for you. And I support Derby County. So I support Derby County. They're in the second league. They're not particularly good at the moment, but hopefully they'll stay up this season in the second league. Okay, so I'm going to stop the video there. Okay, hopefully you found this really, really interesting. Let's see if this uploads fairly quickly, and hopefully this has been useful to you. We can do some more lives. Right. Bye-bye, everybody. Bye-bye. Bye-bye, wherever you are in the world. Bye-bye. 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 I have a good rest of my day. I will do. I will do. All right, bye-bye, Abdul. And bye-bye, Ifunanya. Hopefully I've said that correct. And I'll do some more lives in the future. Okay, bye-bye.